Hi, welcome to another lesson with Dr. Hill. What we're going to do today is continue our learning about electrical circuits. And in our last lesson, what we did was we were looking at what happened when we connected two LEDs in series using a 3-volt power supply, and nothing happened. The LEDs still had current and voltage going through them, and yet we couldn't see any light. And it was because each LED didn't have enough voltage to push the electrons across the gap in the diode and light up and show us an LED lit. Now, there is a way to connect two LEDs up to a single 3-volt power supply, and that's what we're going to look at today. So let's have a look at the circuits on the board here. If we come across and have a quick look, I'll show you that up here, and let's just concentrate on this one for the moment. Up here I have our original circuit. I've just drawn it slightly differently, and previously I had the resistor here. Now I'm putting the resistor along this line. All right. Now the voltage, as normal, comes out of the battery into the resistor, into the positive end of the LED, the positive leg, and the long leg, and back to the battery. And if we connect that up, we'll see that that's working. So I've connected that system up here, and we'll see it working. Let me get my red into the red rail and the black into the black, the negative end of the battery into the black rail, and as you can see, the LED lights up nicely. Okay, the power's coming down the positive, out through the resistor, down into the long leg of the LED, through the LED, and back to the battery. All right. Now remember last time when we connected up a circuit, we connected up an extra LED onto this position in the circuit and nothing happened. We lost the power, and yet there was 1.5 volts going through each LED. Let's see what happens in this circuit. Now, in this circuit, get that out of the way just for a second. In this circuit, what I've done is, instead of putting another LED after this resistor on this single loop, what I've done is I've created a second loop. So I've got the same resistor and another LED. So let's think about what's going to happen to the current. The current's going to come out of the positive end of the battery. It will go around here, and then at this point it has a choice. It can go this way or it can go this way. Well, the fact is it goes both ways. So the current comes around, goes through the resistor, gets reduced to the right current for an LED, goes through the LED and back to the battery. The second way it can go is down here, through the resistor and through the LED and back to the battery. It won't go this way because the electricity will only flow one way in each wire, and it will flow the direction back to the battery. So the current will always be flowing in that direction from positive to negative. All right. So over here, what I've done is I've connected this circuit up. So I'm going to put my negative end into the blue rail and my positive end of the battery into the red rail. We'll do that in just a second. So into the red rail, it comes around, it'll go around this resistor and connects to the positive end of the LED and back to the negative terminal of the battery. So that's one circuit. And then down here, it's going to connect to the resistor and back to the positive end of the LED and back to the negative end of the battery. So that's two circuits. So what I've done is I've built this circuit using the breadboard. Now let's see what happens when we connect up the power supply. So the red goes into the red rail, the black goes into the black rail, and as you can see, the two LEDs have lit up pretty much equally. Now, there's one thing I want you to notice here. Just try and remember how bright those LEDs are, because it does actually kind of depend what angle you look at them at. We're looking straight down the LEDs. We're looking straight down this LED up here as well. Just try and remember that brightness. And we'll look over here. And is that as bright? Probably is. So let's think. We've connected up two LEDs. Now we've got them both working. We'll do it again down here. We've got them both working, and they're both just as bright as an LED on this circuit. Okay, so we're seeing equal brightness, the LEDs in this circuit as we see in this circuit. Now what is this? So in this particular case, we have our resistor and our LED. These two components are connected in series. In this case, what we have is a resistor connected in series with an LED, and that goes back to the battery, but we have an entire other circuit connected to the same battery, and it's a resistor and an LED also connected in series. But what's happening is that the electricity is coming out, the current is coming out and through this circuit, and the current is coming out and through this circuit. So it's going through both circuits. So we have two circuits connected to one battery. So two circuits connected to one battery, and we call that connected in parallel. So these circuits are parallel to each other, and they each are connected separately to the positive end of the battery. Now, that's as far as I want to go in this lesson. What we notice, though, is that when we connect LEDs in parallel, the LED circuit, if you like, the resistor plus the LED, if we connect these in parallel, we get just as bright an LED as we do when we connect it, one of them just connected. And when we connected them in series, we get no light at all. So what's going on? Well, in our next lesson, what we're going to do is we're going to have a look at these circuits again, and we're going to measure the voltages across each of the components, and we're going to find out what happens to the voltage from the battery in these two different circuits. Is it going to be shared right across all the LEDs? Well, it seems unlikely, because we already know that if we share the voltage across two LEDs from one battery pack, then they don't light, but these have lit. So what is the difference? What's the difference between this circuit and the previous circuit? And the only way to find that out is to measure it with the voltmeter, and we'll see. Okay, so we'll do that in our next lesson. We'll look at the voltages across each of the components in the circuits, and we will see how that system is working. All right, so I'll see you in the next lesson. Hope you enjoyed that.